Hi everyone, I'm Vishwanath. Today I'm here to talk about machine learning being used in interesting but yet unusual problem areas such as preventive maintenance. The American Society of Civil Engineers estimates that US is going to spend a ton of money by next year on its aging and failing infrastructure. A classic case to consider is the water mains, which are under the roads of a lot of cities that supply water to all of us. Some of this infrastructure was laid out probably more than a century back in some of the older cities, and now they're showing problems. So, in fact, there were more than 240,000 water main breaks per year in 2010, and it's only going to increase. And this causes a lot of disruption to businesses and households, as you can see in that image. It causes a lot of impact to the economy as well. The worst is part of it is that there's no prior warning to these leaks and these breaks. So they happen all of a sudden and they're very difficult to predict. Uh, so what does the city do today? They just are reactive. If there's a break, they just go and fix the break or replace the pipes. There's hardly any preventive maintenance being done with the volume of the breaks that are happening because they can't target where to go and do the preventive maintenance. There's too many pipelines laid out. What if there's a better way of solving this problem through machine learning and able to predict exactly where the break is going to happen, right? That's exactly what the city of Syracuse, New York did. They had a huge problem and they had tried some statistical techniques like Poisson regression to predict the number of breaks that will happen, but they were not very effective. To address this, the city partnered with the students from University of Chicago through Eric and Wendy Schmidt Data Science for Social Good Fellowship. Uh, and the goal here was to identify the top 1% of city blocks, not the water main pipes itself, but the city blocks, which have the highest risk of a break over the next 3 years. So, how did the team go about doing the machine learning and solving this problem? They had a bunch of data sets like water department work orders, which had all the data about the work that was being done to repair these water mains in the past few years. And the water system main data had all the data around the materials used on the pipelines and the diameter and things like that. Also, previous property taxes paid by the citizens of the city, and notebooks, field notes, and things like that. So the interesting part comes where how did they go about extracting the features required for their model. So some of the old handwritten notes, as you know, the infrastructure is so old that not everything was digitized. So they had to digitize this handwritten field notes in for certain records wherever they couldn't find the records. And then instead of and some they didn't have some of the data on when the pipelines were installed in certain areas, so they used the historical property tax data to determine that was interesting. And based on the installation year, they also they determined whether the pipe was made out of certain material or certain size or certain specs, because for different eras, like the 1920s they used a different kind of materials, and 1940s I think there was a different, and 60s, and so on and so forth. So that was interesting way of imputing certain values based on the other data, missing data. On the modeling, it's a binary classification problem. They asked a simple question: will the water main break in the next 3 years? Yes or no. It also spit out additional risk score for each of those city blocks, and they used Gini index to determine which of the features were important. They determined that certain features are more important versus not, and that was used to construct the model. And they used a bunch of methods like decision trees, logistic regression, adder boost, random forest, gradient boosted decision tree. So we've seen all of these in our class. So how were the results? Well, the gradient boosted decision tree model performed the best with 62% accuracy, which means the 32 out of top 52 breaks predicted were correct. And that beat the previous best prediction by over 14%, which is a good improvement. The biggest lesson learned for the team was that data quality is the most important thing for machine learning, which we all know in the class. Most of the time went in making sure that data quality was right and having all the features created. Benefits of this was multiple departments could work together, align themselves better to make sure that they only dig once. So it helped the city save a lot of money, and serves as a proof of concept of how preventive maintenance could be done by cities using machine learning, and it's gonna really be more efficient than the current techniques. Thank you so much. Bye.